If you have type O blood, you share a blood type with the Mesolithic hunter-gatherers who painted the cave walls of Lascaux. If you have type O blood, you share it with the Neanderthals. We covered that story in our previous videos, and thousands of you asked the same follow-up question in the comments: what about type A? If type O is the ancient blood type of the hunters who followed mammoths across the tundra, where did type A come from? Who created it? Which people carried it first? And what happened to those people? The answer is one of the most consequential stories in human prehistory. The people who carried type A blood were not marginal or obscure. They were the ones who invented agriculture, who built the first permanent settlements, who created the first pottery and domesticated animals. Approximately 8,000 years ago, they left their homeland in what is now Turkey and spread across Europe, transforming the continent. If you have type A blood today, you carry a molecular legacy of that transformation. The ABO system classifies blood according to protein markers, called antigens, that sit on the surface of your red blood cells. Type O has no A or B antigen. Type A carries the A antigen. Type B carries B, and AB carries both. The A antigen is produced by an enzyme encoded by the A allele. This enzyme adds a specific sugar molecule to the cell surface. The immune system recognizes this as self if you are type A, but as foreign if you are type O or B. The genetic difference between type O and type A is small, a few key mutations that allow the enzyme to build the A antigen, but small differences can have enormous consequences when they affect survival in the first densely settled, agriculturally organized communities. The story of type A blood begins in Anatolia, the large peninsula that forms the Asian part of modern Turkey. It stretches from the Aegean coast in the west to the borders of Mesopotamia in the east, acting as a bridge between worlds. Anatolia was the source of the agricultural revolution that transformed Europe, though farming also emerged independently in China, Mexico, and sub-Saharan Africa. Around 10,000 years ago, hunter-gatherer communities in Anatolia began a gradual transition to settled agricultural life. Earliest evidence comes from sites like Aşıklı Höyük, where traces of village living, early cultivation, and organized food storage appeared around 8 to 200 BCE. By 7000 BCE, Neolithic farming was established at Höyük, one of the world's first cities, featuring densely packed mud brick houses. A 2025 study analyzing DNA from 30 individuals found that these early farmers had a distinct genetic profile. They were set apart from hunter-gatherers of Europe and populations of the Fertile Crescent, carrying specific mitochondrial and Y chromosome haplogroups. Crucially, they carried the A allele of the ABO gene at high frequencies. But why would farming select for type A over type O? The answer lies in the disease environment agriculture created. Mobile hunter-gatherers lived in small bands with limited epidemic infectious diseases. Their diseases were primarily parasitic. Agriculture changed this, creating permanent settlements and high population density where infections could spread efficiently. Proximity to domesticated animals like cattle and pigs served as reservoirs for zoonotic diseases that could jump to humans. Stored grain and standing water attracted rodents and insects, further concentrating pathogens in these early farming villages. The immune system had to adapt. Evidence suggests the A antigen confers specific immunological advantages in dense settlement environments. Type A individuals appear to have stronger responses to bacterial pathogens and may resist viruses that thrive in poor sanitation. Over thousands of years of natural selection, type A became common as these people survived the Neolithic disease gauntlet at higher rates. Around 8,000 years ago, the Anatolian farmers began to move, expanding across the landscape into Southeast Europe via the Balkans. Europe was already inhabited by Paleolithic hunter-gatherers with high frequencies of type O blood. They were culturally and technologically distinct. In some areas there was peaceful coexistence. In others, farming populations replaced hunter-gatherers through sheer demographic reality. Farming can support 20 times more people per square kilometer. Over 2,000 years, the genetic landscape of Europe was transformed. The high type O frequencies were diluted by incoming type A. Modern European populations were fundamentally shaped by this ancient encounter. The ancient DNA evidence for this story has become extraordinarily detailed in recent years. We can now directly measure blood type frequencies in ancient European populations at different time periods, and the picture matches the historical narrative precisely. In ancient hunter-gatherer populations from before the Neolithic transition, individuals who lived in Europe between 15,000 and 8,000 years ago, type O dominates. Type A is present, but relatively rare. This confirms the basic picture. The original European population was predominantly type O. In early Neolithic European populations from the period of agricultural expansion, individuals who lived in Central Europe between 7,000 and 5,000 years ago, type A becomes dramatically more common. These are the descendants of the Anatolian farmers and their mixed offspring with local hunter-gatherers, and their blood type frequencies reflect the incoming A allele from the farming populations. By the Bronze Age, around 4,000 to 3,000 years ago, the pattern begins to approximate modern European blood type distributions, with some important regional variations that reflect later migrations from the Eurasian steppe. The story that the ancient DNA tells matches the story that population genetics predicted. Type A in Europe came primarily from the Anatolian farmers. A 2025 study from the University of Ferrara, analyzing ancient pigmentation and genetic markers in 348 ancient individuals, confirmed that the Neolithic transition in Europe was associated with a dramatic change in the genetic profile of the population, including blood type frequencies. The study found that the Anatolian-derived ancestry that spread across Europe was the primary driver of the elevated type A frequencies. The Anatolian farming expansion explains the high type A frequencies in Europe, but type A is found around the world. Understanding its global distribution requires understanding that the Anatolian farmers were not the only group that carried high type A frequencies. Type A is also common in parts of East Asia, particularly in Japan, where it is actually the most common blood type. This Japanese type A has a different origin from European type A. It reflects the spread of the Yayoi farming culture from the Asian mainland. This migration transformed the genetic landscape of Japan in ways that parallel what the Anatolian farmers did to Europe. Among Aboriginal Australians, one of the most genetically isolated populations on Earth, whose ancestors arrived approximately 50,000 years ago, type A frequencies are also relatively high in some populations. This shows type A is not exclusively associated with farming populations. The A allele existed before agriculture. What agriculture did was dramatically increase its frequency through the selective pressure of the new disease environment. In the Middle East, the region where agriculture itself originated, type A frequencies are moderate. This reflects both the long history of agricultural populations and the complex mixing of many ancient groups over thousands of years. If you have type A blood and you are of European, Middle Eastern, or East Asian ancestry, your blood type carries a direct ancestral connection to the first farming communities, the people who invented the way of life that ultimately gave rise to cities, writing, and everything we call civilization. This does not mean you are descended exclusively from Anatolian farmers. Modern Europeans carry a mixture of ancestry from at least three major ancient populations: the Western hunter-gatherers who inhabited Europe before farming arrived, the Anatolian farmers who brought agriculture, and the Yamnaya steppe pastoralists from the east. All three contributed to the modern European gene pool. Your type A blood reflects primarily the Anatolian farmer component of that mixture, and the disease selection that drove type A to high frequencies in farming populations left other traces as well. Type A individuals have a somewhat higher risk of cardiovascular disease and thrombosis than type O individuals, a disadvantage in the modern medical environment, but one that was presumably outweighed by the advantages type A conferred in the disease-intensive environment of the Neolithic village. Every blood type is a compromise, an adaptation to a specific historical environment that carries different costs and benefits in different contexts. The people who first carried the A antigen at high frequencies are gone as a distinct population. They were absorbed into the broader genetic mix. But the molecular marker they carried The A allele, the enzyme that builds the A antigen, is still there, in your blood. Right now, a direct molecular connection to the people who first planted wheat in the highlands of Anatolia 10,000 years ago. The ancient farmers of Anatolia who changed Europe. The disease environment of the Neolithic village that selected for type A. The migration that transformed a continent of hunters into a continent of farmers. And the A antigen on your red blood cells. A molecular echo of a transformation that happened 10,000 years ago and that created the conditions for everything we call civilization. Your blood type is not just a medical category, it is a history written in protein on the surface of your red blood cells, connecting you to specific people, specific places, and specific moments in the deep human past. Subscribe to Hidden Origins, because every blood type has a story. Drop a comment. Did you know that type A blood is associated with the first farming communities? And what blood type do you have, we want to know.